Okay, this lesson is on section 3.6, equations for lines in the coordinate plane. This is going to lead us into equations for lines, specifically parallel and perpendicular. Quick review for the equations of lines that you have learned in previous classes. Review of slope. Remember that slope is the rate of change for the line. You may have heard of it as rise over run, or the difference in the y's over the difference in the x's. Remember, the y's give you the rise, the x's give you the run, and that's how you find the slope. The intercept, or when we talk about intercepts, that's where your line is going to cross an axis. So the x-intercept is where it would cross the x-axis, the y-intercept is where it would cross the y-axis. You've learned two different equations for lines. They do the same thing, they just are in two different versions. The first one is slope-intercept form, y equals mx plus b, where x and y are coordinates of the points that lie on that line, and m stands for the slope of the line, or the rise over the run, and then b represents the y-intercept, where that line crosses the y-axis. It's best used for writing the equation when you are given a point and the slope. It's also used best for if they give you that equation, it's the easiest one to graph. For example, if they give you y equals 3/4 x minus 6, that means that where it crosses the y-axis is at -6, so you would count down 1, 2, 3, 4, 5, 6, and that's where that's the point where it would cross the y-axis. And then your slope, your rise over your run, would be 3/4. So from -6, you would rise 1, 2, 3, and you would run 1, 2, 3, 4. And then once you have 2 points, that determines the line. So you would draw a line through your points, and that's the line that is represented by that equation. Another version of an equation for a line, it looks a little more intense than this one. It's not necessarily. It's called the point-slope form of the equation. The only difference is here in the slope-intercept, all you can take out is the y-intercept and a point, or excuse me, a y-intercept and the slope. Over here, you can use any point. It doesn't have to be the y-intercept. It can be any point that's on the line. You still have m for slope, you still have the x and the y, which stand for all the points that are on the line, but then there's an x1 and a y1, which is a specific point that you are given that has the x and y coordinates to it. It just doesn't have to be the y-intercept. So point slope opens it up for a little more user-friendly activity. Point slope is used best for writing the equation if you don't know what the y-intercept is. If you know 2 points, or if you know the slope and 1 point that's not the y-intercept. Okay, so an example of that, write the equation for the line with a slope of -2 that goes through the point -1,4. Notice -1,4 would not be a y-intercept because it would be up here. So we do not want to use the slope-intercept form, we will use the point-slope form. To do that, you simply plug in the parts that you know. The y stays, because that stands for all the y coordinates of the points on the line. And then y1 would be our y coordinate of the point that we know. So it would be -4. Notice that the minus is part of the formula, so that stays there. The only reason it would change to a positive is if this number is negative, because then 2 negatives would make a positive. You put the slope outside the parentheses, so we will put -2 outside the parentheses. And then in the parentheses, this x represents all the x coordinates for the points on the line, so that stays. And then minus, and then you put in your x1. Now our x1 is a -1. So since there's a minus already in the formula, when I put in -1, it changes it to a positive. So the equation of our line would be y minus 4 equals -2 parentheses x plus 1 end parentheses. And you can simplify that down if you want, but you certainly don't have to. This is an appropriate way to leave the equation of this line. We're going to talk quickly about horizontal lines and vertical lines because their equations look a little bit different than regular diagonal lines. And that is because horizontal lines never cross the x-axis and vertical lines never cross the y-axis. So they wouldn't have intercepts, so to speak. So horizontal lines will always be in the form of y equals, and then wherever it crosses the y-axis, that's the number that goes here. Vertical lines always have the equation x equals, and that's because they cross the x-axis. And on the other side of the equal sign, you would simply put the x-intercept where they cross the x-axis. So let's look at a couple of points here. The first one, it says take the point 4, -3. So we have to find the point 4, -3. So 1, 2, 3, 4, and then 1, 2, 3. And we're going to put a point right there. Let me put it where it's supposed to go. Okay. Now, what we are going to do is it says draw the horizontal and vertical lines through that point. So I'm going to take my line tool. I'm sure you guys have one of those in your notes, right? And I'm going to draw the horizontal and vertical lines that go through that point. I'm going to draw them big enough so that I can see where it is they cross those axes. So now what I'm going to do is write the equations for those lines. The vertical line crosses the x-axis, so it has the equation x equals. And all I do is figure out where it crosses the x-axis. So since it crosses at +4, the equation for my line is x equals 4. As far as my horizontal line goes, horizontal lines are y equals, and that's because they cross the y-axis. So my equation for that line would be y equals, and where does it cross the y-axis? It crosses at -3. So the equation for that line would be y equals -3. Notice that that directly relates to the point itself. Since the point goes through 4 as its x-coordinate, that means that it's going to cross 4 on the x-axis. So that's how another way we could get x equals 4 for the vertical line. And my y intercept there is -3. So every point on there will cross the y-axis at -3, and so my equation would be y equals -3. So you can get them by graphing them and looking at where specifically they cross each axis, or you can get them from the coordinates of the point itself. Another example is the point -2, 8. So again, if I wanted to write the equation for the horizontal and vertical lines that go through that point, I'm going to have one that's y equals, and I'm going to have one that's x equals. The y equals 1 would be the horizontal line because that's how I'd get it to cross the y-axis. It would cross the y-axis at 8. So my equation would be y equals 8 for the horizontal line. My vertical line goes this way. It's going to cross the x-axis at -2. So my equation for my vertical line would be x equals -2. So notice I didn't even, in this instance, I didn't even have to draw out the lines. I could figure out what the equations of the lines were just by looking at the point on the coordinate grid. Sometimes you have to draw them out. Sometimes it's easier to see them if you draw them out. It's up to you completely. All right, so let's go on to writing equations or reviewing writing equations for regular lines. Not horizontal and vertical necessarily, but let's see if I can get the actual channel or the page to turn. There we go. But to actually write the equations for the lines. Okay, so here we go. If in this instance I am given a slope of 2/3 and a y-intercept of -4. So which one of the two would be easier to write the equation for? That would be the first one, because I can plug in the y-intercept and the slope and I am done. So I'm going to write y equals, and then my slope goes next to my x. My slope is 2/3. That means that the line goes up 2 every time it goes to the right 3. And that's the number that goes next to the x. And then my intercept, my y-intercept goes next. My y-intercept is a -4, so I'm going to write -4. That's how I'd write the equation of that line. So if you're given the slope and the y-intercept, simply plug it into the equation. Well, what if you're not given the y-intercept? If you're not given the y-intercept, you're still given the slope and a point, but notice it's not the y-intercept, then it's easier to use this other equation. Okay, so you're going to write y minus, and then this is your y1 value, the y-coordinate of your point. So it would be 6 equals slope goes next, 1/2, and then in parentheses, I'm going to put x minus. Notice that's all part of the formula, and then I'm going to put my x1 value, which in this case would be 4. That would be the equation of my line. It's in point slope form instead of slope intercept form, but that's okay. No big deal. I could reduce this down and simplify it, and then if I did that, it would end up looking just like this anyway. But it's perfectly okay to leave it in that form. My third example, what happens if I don't give you the slope at all? Well, then you have to find the slope between the 2 points. Okay, going back to what we looked at in the very first slide, was doing the change in y over the change in x. So I would do 5 minus 2, because those are my y values. The difference of my y is 5 minus 2. Over the difference in my x's, I have to do 2 minus 4. You have to go the same way. So if you do this point minus this point, then you have to do this point minus this point. So the slope of my line would be 3 over -2, or -3/2 would be my slope. And from there, I would probably use my point slope form, since neither one of those are the y-intercept. There would be no point in going through the hassle of finding the y-intercept when I already have 2 points I can use. So I'm going to use the point slope form. So I'm going to say y minus, and it doesn't matter which point you pick, but my suggestion is that you mark it in some way, shape, or form so you know that those are the 2 coordinates you're going to use, and so you don't mess yourself up by using one of the other ones. Okay, I'm going to use this point, so I highlight it for myself, and so I do y minus y1. My y value is 5 equals my slope, we just found out, was -3/2, and then in parentheses it's going to be x minus, and my x coordinate is 2. So that would be the equation of my line. It would be y minus 5 equals -3/2 parentheses x minus 2. That would be the equation for my line. If I don't get the slope, I have to find it and then plug it in. Okay. That is the end of this lesson. Your homework is as follows.